Alright, so now that we have a basic idea of what the atom is actually made up of, now we're going to take a look at how we can make some sense of those subatomic particles and figure out how many of each of them we have in a particular atom. So the first thing we're going to take a look at is something known as the atomic number, right? And the atomic number is how the atoms are arranged on the periodic table, right? Specifically, they are arranged by increasing atomic number. So if you look on your periodic table for each of the elements, you're going to see the symbol for the element, and we have here sodium as an example, and right above it you'll see a number. That is the atomic number. And the periodic table starts in the upper left with hydrogen, and there's a 1 right above it. So that tells you the atomic number for hydrogen is 1. And if you follow the periodic table across from left to right and from top to bottom, you'll see that the atomic number increases. 1 for hydrogen, 2 for helium, etc. Now the atomic number is important because the atomic number, abbreviate number here is this, the atomic number is actually equal to the number of protons. And that's a key thing to keep in mind. So what this means then is sodium with atomic number 11 is going to have 11 protons. So just by looking up on the periodic table, we can determine really quickly how many protons are in that atom. It is equal to the atomic number. So what this means by extension is the atomic number, or the number of protons, defines the element. So if I say something has 11 protons, or an atomic number of 11, it can only be sodium. It cannot be anything else. If you tell me something has an atomic number of 10, well, it couldn't be sodium, it'll be neon. Something has an atomic number of 1, it can only be hydrogen, right? So the atomic number, which is the same as the number of protons, defines what that element is. So for example, again, if we look up carbon, we'll see that the atomic number is equal to 6, which means carbon is going to have 6 protons, right? Every single carbon atom will have 6 protons. Similarly, copper, if you look up copper on the periodic table, you'll see the atomic number is equal to 29. So that means that there are 29 protons. So every single copper atom, so each copper atom will have 29 protons, no exceptions. So we can determine the number of protons in an atom by simply looking up where it is on the periodic table and finding its atomic number. The atomic number is equal to the number of protons. So, one thing to keep in mind as we go through this process to determine the number of subatomic particles is that atoms by definition are going to be neutral. And if something is neutral, this means the number of positives, or the number of positive charges, must equal the number of negative charges, right? So they cancel out. So if we have, for instance, an atom, we know that there are going to be our 3 subatomic particles, protons, neutrons, and electrons. Well, the positive charges are actually due to the number of protons, right? Those are the things that have a positive charge. Well, what subatomic particle gives a negative charge? Well, that's the electron. So in an atom, which is by definition neutral, the number of protons is simply equal to the number of electrons. All right, so for instance, if I'm looking at carbon, and I'm looking at the carbon atom, okay, I can look up on the periodic table that it's got 6 protons, which means it is also going to have 6 electrons. Similarly, a copper atom, we look it up on the table, it has 29 protons, which means by definition, if it's an atom, it is also going to have 29 electrons. So we can take a look at a couple examples, and you can use your periodic table to help you figure this out, and we'll do sodium together. So if you look on your periodic table or any periodic table and you find sodium on there, right above sodium you'll see the atomic number, which is 11. So the atomic number is equal to the number of protons, so we're going to have 11 protons, and because this is an atom, the number of protons should equal the number of electrons. So we're going to have 11 electrons in a sodium atom as well. So we've seen how we can determine the number of protons in an atom. We just look up the atomic number. We see how we can come up with the number of electrons. That is simply equal to the number of protons, because by definition an atom has to be neutral. What about the number of neutrons? How are we going to determine that? Well, in order to determine the number of neutrons, we have to know another number called the mass number for a particular atom. And the mass number is equal to the sum of the number of protons plus the number of neutrons. Right? So we're essentially counting the number of particles we have in the nucleus, right? Because that's where the protons and neutrons are found. One thing to keep in mind is that the mass number does not appear on the periodic table. So you're not going to find that on a periodic table. This will actually be provided to you. Or you may have to calculate what it is. And the calculations that we're going to be doing here are actually relatively simple. All they involve are just addition and subtraction. So the mass number is equal to the number of protons plus the number of neutrons. So using that, we can actually do a little bit of math here and figure out how we can calculate the number of neutrons. All right, so the mass number is equal to the number of protons plus the number of neutrons. So then we can rearrange that equation and we can say the number of neutrons is equal to the mass number minus the number of protons. All right, I just move this over to the other side and I change the sign to negative. So this is how we can calculate the number of neutrons. We take the mass number and we subtract the number of protons that are present. All right, so let's take a look at a couple examples in this type of calculation. So let's say that I had sodium. And I tell you that a sodium atom has a mass number of 23. How many protons? How many electrons? And how many neutrons are present in this? All right, so to get the number of protons, we simply look up in the periodic table. right? So we find sodium, which is Na, and when you look sodium up on the periodic table, you'll see it has an atomic number of 11, which means that the number of protons is also equal to 11. To get the number of electrons, right, this is a sodium atom. For an atom, the number of protons is equal to the number of electrons. So there are 11 electrons in a sodium atom. And then to get our number of neutrons, we just did a little bit of math previously. The number of neutrons is equal to the mass number minus the number of protons. So mass number minus the number of protons. So we substitute those numbers in. We were given the mass number of 23. So 23 minus 11 would give us 12 neutrons, right? And it is that simple. It is just a little bit of math that you're doing, but you have to use your periodic table to help you, right? And be able to interpret what information is provided. All right, so you can do this one on your own. So you had an atom of lead, which is Pb, and you're told that it has a mass number of 207. All right, so we can look up the atomic number from the periodic table. That's going to tell us how many protons we have. The number of protons is going to be the same as the number of electrons, because they have to equal each other for a neutral atom. So if we look up the atomic number on the periodic table for lead, we see that it is 82. All right, so it's going to have 82 protons. For a neutral atom, it is going to have the same number of electrons, which is 82. And then the number of neutrons is going to be the mass number, which is provided, 207, minus the atomic number, which is 82. And that's going to give you your answer over here. And I'll let you calculate that on your own. Then the last one I wanted to go through with you is if you're going in the other direction. So let's say now you're told that an atom has 14 protons and 20 neutrons. Alright, so remember the number of protons is the atomic number. Right, these are the same. They're just different ways to represent the same number. So the atomic number here is going to be 14. Alright, your mass number is the number of protons plus the number of neutrons, which is equal to 14, number of protons, plus 20 neutrons, which would give 34 as our mass number. And then what is that element going to be? Well, we said at the very beginning, the number of protons, which is the same as the atomic number, defines the element. All right, so we just look up 14 on the periodic table as our atomic number, and that'll give us Si, which is silicon.